ellipses, and specifically the equation of an ellipse. And we're going to focus in part 1 here on ellipses that are horizontally oriented, meaning the long way is with the x-axis. So let's just start by really identifying some parts of the ellipse. Now there's some wonderful dynamic videos, and dynamic by dynamic I mean there's movement, and you can actually see an ellipse being formed, and so you might, you could Google some of those and find out, how is an ellipse formed, and you can watch that happening. I'm not going to do that here on this video, but you can just, I'm going to just identify some parts of this. But an ellipse has to have two foci. Some people say foci. Anyway, foci. So these red dots I've identified as the foci, and what I know about an ellipse is this, that this right here where the foci are is what we call the major axis. Now it just means that it's the longer axis, right? It's the way that the ellipse is oriented, and on the major axis is always are always the foci. In addition to that, there's always a distance called A. Now A is on both sides, right? Because an ellipse is symmetric. So A is this side or this side, and it's always the distance from the center. Now this center happens to be the origin, from the center to the vertices. Now these are called the vertices. I think some books refer to all 4 of them as vertices, but I think not positive about that. So we'll just call the outermost points of the ellipse the vertices. So from from the center out to the furthest edge on the major axis is what we call A. Okay, and it's from the center out in either direction. So let's take a look at what B is called. B is from the center perpendicular to the major axis. In other words, it's the crossbar. Okay, so this right here is B. That's B. And that's B. Now there is a relationship between AB and this last one, which is, and this last one. This last one is the letter C. We'll call that C right there. And the C is from the center. Notice everything is oriented from the center. It's from the center to each focus. Okay, from the center to the focus on each side. Okay, there are 2 foci. All right, so let's take a look at the relationship between the A, B, and the C. It kind of looks like the Pythagorean, but it's not. It's A squared minus B squared. Okay, now in this particular illustration, I'm just going to go ahead and show you the distances, and let's just see how these distances reinforce this relationship. So in our picture, I see that my A is 10. I see that my B is 8. If you count them, you'll see that. And my C is 6. Whoops. My C is 6. So we're going to plug those in. So 6 squared, there you go, there's that. Then I have 10 squared, which is 100. And then I have 8 squared, which is 64. Now let's take a look at the relationship here. Alright, so is that true? Oh, sure it is. Okay, so that relationship is true, and about these relationships are true on all ellipses. Okay, so let's go to the second. Now that we have the basic parts of the ellipse, let's go to another example and how we would actually go about graphing an ellipse if we're given just some of the parts. So If it says to graph the ellipse, so let me go move down a little bit now that we know what the directions are. So I'm going to graph this thing, and I'm going to start by just putting the information on the coordinate plane, as I see it. So I'm going to go ahead and put the foci on there. That's 6, 0. 1, 2, 3, 4, 5, 6. I'm going to try to be consistent with the colors. And then negative 6. 1, 2, 3, 4, 5, 6. Now this is not exactly what we just did. It's a different shape. Okay, so now the vertices, that's related to, right, to the A. So I'm going to make that blue. So that's 8 and negative 8. So that's 8 and negative 8. And that just means this. It just means that's as farthest this thing goes on either side horizontally. The farthest it goes horizontally. Okay? So now all we need is this blue B, right? The vertical distance, the crossbar. And then we can go ahead and finish graphing this ellipse. So let's take a look at the relationship between the A, B, and the C. And we'll just solve for B. So what was C? C was the blue stuff, which is 8 squared. I'm sorry. C was the 36, 6 squared. A is the 8, which is 64, minus B squared. Okay, let's recap that. We know that A, my goodness gracious, come on, pen. There we go. It is certainly not wanting to respond. A in this case is 8. C in this case is 6. And what I don't have is B. Alright, so let's keep going here. We have 36 is equal to, pardon me, so we have negative 28 is equal to negative B squared. I subtracted 64 from both sides. I'm going to divide by negative, and I get B is equal to the square root of 28. Now, you never want to leave these unsimplified. I know that a 4 is in there hiding, and so I'm going to say that that's 2 square roots of 7. And of course, when we take the square root of both sides, right, we insert a plus or minus, but because it's distance, we're going to choose the positive one. All right? Okay, so B is 2 square roots of 7, which is roughly 5.3. All right, so let's go ahead and finish putting our green B on there at 5.3. 1, 2, 3, 4, 5. Close enough right there. That means that's the highest this thing goes. 3, 4, 5.3, right about there. That's the lowest it goes. Okay, let me go ahead and get my pen to sketch. You're just going to always sketch a smooth curve, as smooth as you can. There's never a straight line on an ellipse, never straight. Never points, never straight. It's as smooth as you can get it. Okay? All right, I have one more thing to do, and then we'll move on to the next video. So there's my ellipse, and here we go. Last one. Now this time it's asking for the foci. The way I approach this, it's not necessarily the way everybody does, but the way I approach this is I actually do start with a drawing. I don't start with the formulas or anything like that. I start with the drawing. So they give us some y-intercepts. Now we're not sure what in the world those are. We just put the points on here. We've got over 0 up 3 and over 0 down 3. So we've done that. Now the vertices, we have 8 and negative 8. 1, 2, 3, 4, 5, 6, 7. There's 8. 1, 2, 3, 4, 5, 6, 7, 8. And even if they didn't call them vertices, if they just said x-intercepts, we would know that this is horizontally oriented, right? And so we would know that this is our A. We would know that this is our B. And we would want to get the C, right? We don't know where the foci are supposed to be placed. And so this just helps me to realize that the foci are going to be on the x-axis. Helps me to identify where they are. Okay, so in the next video we'll have some examples of where the foci are not on the x-axis. So that's adding a few more steps. Here we go. C squared is equal to, pardon me, try to be consistent here. C squared is equal to A squared minus b squared. So we have c is I don't know, and a is, what was a? 8. 8 squared minus 3 squared. So we have c squared is equal to 64 minus 9. And we have c squared is equal to 55. We take the square root. We normally would put plus or minus, but, well, we do put plus or minus. So we're going to go ahead and put plus or minus, but we're going to pick the non-negative one. So we get the square root of 55, which is approximately, what is that, 7.4? Okay, so c is approximately 7.4. I'm going to go ahead and put the foci on there at 7.4. Now, if those foci ended up sitting outside the ellipse, we would have a problem. So it's kind of, it's a little bit it's kind of self-checking. I mean, it's not always, it's not foolproof, but it does help. 7.4 approximately there, and 7.4 approximately there. Now let me see if I can get this sketched. Now it didn't say to actually graph it, but you know, I'm just making sure everything looks right. Right, my foci are inside it, things like that. Okay, so I hope this was helpful, and stay tuned for the next video, part 2. Thanks for watching.